Maths guys, we're looking at a few past exam questions. The first one that we're looking at is a pure maths question based on logs, and we need to, in the first step, turn this equation into a quadratic expression. Step one, we need to make sure that we've got everything in log form. This is log base 10, so that's okay, but you will notice that the first term on the other side is not. But we can turn that into log base 10. That is 100. Log 10 of 100 is 2. And then we now have everything in log form, and we can start using our log rules to simplify things. So here we have x minus 4, and using our log rules we can simplify this side to log base 10, 100 over x. Now that we have logs on both sides, we can move straight to x minus 4 is equal to 100 over x, right? Get rid of our log on both sides. When you have a log base 10 of something and log base 10 of something on the other side, once you've just got one of each of those, then you can get rid of that log. Okay, so now x squared minus 4x is equal to 100. I've just multiplied both of my sides by x, and then I'll pull this over here, so I have my quadratic expression, my quadratic equation. Okay, that's the first part. The second part of the question asks us to solve this equation and give our answer to 3 significant figures. Now you might be thinking, that's a bit weird, one answer, shouldn't there be 2? Well, and it says to 3 significant figures, so obviously we're going to be using the quadratic expression. So minus b, which is minus 4, plus or minus the square root of b squared, minus 4 times a times c, and we're going to pop that all over to a. And when we simplify this, we're going to get, so this is what x is equal to, we're going to get all the way up here, x is equal to, and I get 2 plus or minus 2 square root 26. Those are the 2 results I get in my calculator, but you notice that this says there should be only one answer, because it says giving your answer, not giving your answers. So one of these answers is not going to be required, or is there something wrong with it. Now think about what we know about logs. Can we have a log of a negative number? So if you just get your calculator now and go log and put in minus 2, you'll find that it's undefined. Logs are undefined for less than 0. So if we chuck in 2 minus 2 square root 26 and pop that into here as our x value, you will see that you get an undefined value. So therefore our result is x is equal to 2 plus 2 square root 26. And that's how we do the first one. The second question asks us use the iterative formula to find correct to 4 decimal places what x's value is. I'm not going to do this one because I feel like most of us are able to do this, but if you are having trouble, do email me and I can actually show you that. I just want to save time and move straight on to the second question, and it says state an equation satisfied by alpha and hence find the exact value of alpha. Well, you'll notice in the equation above you've got this x n plus 1 equals 2x to the 6 plus 12x all over 3x to the 5 plus 8. Okay, that is the equation satisfied by alpha. Okay, they have the n's in here, but we're going to take those out. This is the equation satisfied by alpha, and now we've got to actually solve the equation and find the exact value of alpha. Okay, so I'm going to multiply both sides by x, and this will give me this. I'll move everything across to one side, so I'm going to get x to the power of 6 minus 4x is equal to 0, and now I can solve the equation. X into x to the power of 5 minus 4 equals 0. Now you have two answers to this equation, x equals 0, but it can't be that, because if you look at your answer to part 1, that's not what alpha is. So the other one is x must equal the fifth root of 4, because the fifth root of 4 to the power of 5, take away 4, will give us 0 in this bracket. So that's the answer to our second one. So the next question is a trigonometry question, and I hope you notice that you're going to need to use your addition rules. I've just popped them up here so that we can look at them if we need to as we're doing this. Sine A plus B is equal to sine A times cosine A plus cosine A times sine B, and then cosine A plus B is equal to cosine A cosine B minus sine A sine B. Okay, we're given this equation here. We know that sine theta plus 45 plus 2 cosine theta plus 60 is equal to 3 cosine theta. So we've got to find the exact value of tan in a form involving surds. Okay, the exact value of tan. So first step is to use our addition formula. So I'm going to go sine theta cosine 45, I'm using this here, plus cosine theta sine 45, plus, and then I'm going to do a big bracket here, 2, and I'm going to use my cosine addition formula here, cosine theta cosine 60 minus sine theta sine 60 is equal to 3 cosine theta. Now, after I've done that, I want to simplify all of this. So you can check on your calculator. I'm going to simplify this to square root 2 over 2 sine theta, and I'm going to simplify this to square root 2 over 2 cosine theta, and I'm going to simplify this to 2 times, and then this one cosine, so this will be 1/2 cosine theta, whoops, don't get rid of the bracket yet, and this one will be minus square root 3 over 2 sine theta equals 3 cosine theta. Now I'm going to multiply out this bracket here, so this ends up being plus cosine theta, and when I multiply this out by 2, it'll be, just minus square root 3 sine theta. Okay, I hope that makes sense. Now we're going to gather all of our like terms. I'm going to put all my sines on one side and all my cosines on one side. So on your calculator, you can just go square root 2 over 2 minus square root 3, and that will give me minus 2 square root 3 plus square root 2 over 2 sine theta. I'm going to move this cosine and this cosine over to this side by subtracting both of them. 3 minus square root 2 over 2 minus 1. And that will give me this value here, 4 minus square root 2 over 2 cosine theta. Now I want to get my tan theta, so to do that I'm going to divide both sides by cosine theta, and that will give me minus 2 square root 3 plus square root 2 over 2 tan theta equals 4 minus square root 2 over 2. I've got rid of my cosine from both sides. Now I want to get rid of this, so I've got tan theta on its own, and I'm going to go this divided by this. But since we've got the same denominator in both cases, that will cancel out, and you'll end up with minus 2 square root 3 plus square root 2. And that is our answer to the first part of the question. The second part says hence, which means you're going to use what you've got here. We are going to solve that equation for 0 degrees is less than theta is less than 360. So to get theta by itself, I'm just going to go theta is equal to the inverse tan of this. Make sure you set your calculator to degrees, and I get theta equals negative 51.6 degrees. Now that's not in our range, but we can easily just refresh our memory, we know that our tan graph looks something like this, with this being 180, this is 360, 0, minus 56 is here. So to get our other two values, we're just going to add 180 to get this one, and we're going to add 180 to get this one. And so my two values are going to be 128.4 degrees, and this one here will be 308.4 degrees. And those will be my two values. Well, I think that's it for today from the Pure Maths work. I hope these videos made sense to you. I hope they've been helpful to you. And that's all about Pure Maths work for the term. I hope you have a great holiday and enjoy yourselves. Don't get too bored. And I'll see you next term.